A very warm welcome for this session on object-oriented programming. Let us see our learning objectives for this session. After going through this course, uh, these are the learning objectives identified. State why is object-oriented programming a paradigm, okay? And state and explain the key terms of object orientation. So any language would be having some building blocks. So object-oriented programming has these classes and instances as the basic building blocks. Okay, so in this session we would be having a clear picture about what are these classes, instances, methods, and messages. In the coming classes, we would also be seeing about what is this encapsulation, information hiding, then inheritance. Okay, so encapsulation, abstraction means information hiding, then inheritance. These are the basic pillars of object oriented programming. Now firstly, let's understand what is this object. Okay, anything in the universe is called as an object. Anything that a human eye can see. Okay, so they can be tangible things like a car, a paper, a circuit, a ellipse, okay, any geometrical shape, any living person, right? Anything, any object in the world. The universe is composed of so many objects, so many objects. Anything on noun form. In English language, we use nouns, right? Nouns are nothing but name, place, thing, animal, why not bird, anything which is living or non-living, or anything which is uh, visible for the human eye is called as an object. Okay. Now, once you see so many objects around, uh, every object plays a role, or every object starts communicating with each other for various reasons, right? This communication form is nothing but message passing. That means two or more objects are trying to interact with each other, and two or more objects are trying to transfer some information between each other, right? This is nothing but message passing, right? So you have objects first, which are tangible things, and objects try to communicate with each other, and the way objects communicate with each other is nothing but message passing. And during this passing of messages, you call the first object, whatever is sending the message, is as a sender object, and whatever is receiving an object is receiving a message is called as a receiver object, obviously. So they play a role, a particular role. Like suppose there's a person who is passing a message. So that person is called as a boss. Boss will actually pass message to the employees. So the role that they play, the sender takes up a role that he is passing a message. So that taking up a role is nothing but an employee. The taking up a role is nothing but a boss. So this is nothing but role, right? And each person is playing a role. So which is nothing but a message passing. Okay. Now the moment there is a message passing between objects, there is certain incident that is happening, right? There is certain event that is taking place. Events like you have a flight journey, right? Which is nothing but you have to plan your itinerary. Similarly, you have overflow of a stack, right? Which is nothing but a situation, which is nothing but a state of an object, right? If you suppose that stack is an object, then you have little overflow, right? Overflow is nothing but a special event or an incident that is taking place. So that event or this situation is called as an incident. Okay, similarly you have some interactions happening between these objects. Okay, so certain class of these messages can be characterized and we call them as a contract. So these are nothing but incidents. Let us now see that there are some interactions. So what are these interactions? Let us uh, pause for a while. Now I have a reflection spot question. I have a reflection spot question. Please pause here. Now what do you, yeah, the reflection spot question is, can you specify what are the specifications of an object called as? Right, every object exhibits certain characteristics, so these characteristics you call them as specifications, right? uh, Rather, we can call them as characteristic features of an object. So the reflection spot question is, how do you identify certain attributes that are associated with an object, right? Are they the physical characteristics of an object, or the chemical characteristics of an object, or what are these characteristics? Okay, what is it dealing about? So please pause for a while and then take a note of this reflection question spot. So now let's proceed for the next one. Now, what are these objects? Objects are nothing but an individual item, so which is an abstract, and anything to which a concept applies. Okay, so what do we actually basically care about these objects? Why do we care about these objects? So, how are these objects related to our programming? When it comes to real-time programming, what is happening is, in the procedural style of programming in the C language, what we have seen earlier, we find that the execution, I mean the program execution, is a step-by-step approach, and it is always divided into certain modules, right? So C programming, the functions are split up into certain modules, and each of these modules are nothing but pieces of code where you can execute. Okay, there you have seen something called as modularity, where large software projects can be split up into smaller pieces. Okay, and this modularity is very well observed in your procedural programming. And how about this object oriented programming playing a vital role in this achieving this modularity? In fact, to put forward, object-oriented programming achieves 100% modularity in solving a problem, because you cannot have any statement loose inside a program. You should have them, everything combined together into a module. That means into a method, in the form of a method, which can be clubbed together into a unit, right? Now here, in object-oriented programming, everything is composed of objects and interaction between objects, and which actually provides or gives you an opportunity to reuse. So which is nothing but reusability, right? So once you assemble these components together and you compose them into a module, these modules are reusable and extensible as well, right? Sometimes you write a generic module, and these generic modules can be extended further, can be developed from the existing ones, and this is how this complete object oriented programming is composed of. Okay, so now how do you call them as, why do you call them as an object oriented programming as a paradigm? Okay, so programming is nothing but, here object oriented programming is nothing but a paradigm. What do you mean by paradigm? Paradigm is nothing but the way of viewing the world, right? The way of viewing the world. Suppose there's a small problem before you, so you would solve it in your own approach, your own style, and the other person, your friend, may be solving the same problem in some other style. That means, from his perspective, the problem or the solution to the problem could be different. So that is what it is all about. So object oriented paradigm is nothing but a way of viewing the world. Okay, so the approach of solving that particular problem. Okay, now in this approach, there is something called as, there is a sequence of computations that you perform in order to solve a problem. Now this sequence of computations, the way you arrange, is nothing but the algorithm, right? So to realize this algorithm, what you do is you actually go in the process of achieving that particular task. That means how the data is to be structured internally, and in order to solve, I mean, inside the computer for problem solving. Okay, that is what is nothing, called as a paradigm. Now, what is object-oriented programming? So let us suppose the object to be as a black box, like a gift box. So usually what do? You don't give your, you actually wrap up your gift completely in a good gold color wrap, and then you tie it under so that there is some certain surprise element involved inside it, and all the complexities of the gift item, whatever you are packing, is hidden from the completely the outside world. So outside world, whoever is viewing you with a gift box in your hand, they don't know what is inside completely. That means you're hiding away the internal details of the gift, the specifications of the gift from the outside world. So that's the reason why we are showing you a black box here. So the object is like a black box. The internal details are completely hidden. Okay. So here you can see that any object is not exhibiting its characteristics to the outside world. Okay. So you identify an object, and an object actually communicates with other objects, sends some messages, exhibits certain characteristics. All these activities are there, but it is hidden from the outside world. That means messages are received by the methods of an object, but it is hidden from the outside world. Outside world is able to see only the aim of the object, that it is a gift, it need to be delivered to a proper person. That's all. So internal details, specifications, the attributes, the length, width, the height, etc. What are the functionalities it will deliver, all are hidden. So now let's proceed on with the composition of an object basically. Okay, so when it comes to composition, you can see that there is a class, and there is some private data, and there is some public process. So let's come back to this a little later. Okay, now let's go on to what are the basic two parts of an object that is playing a vital role. The object is composed of certain attributes which it exhibits, which I call them as data, and certain activities that you perform over that object. So these activities are nothing but methods, certain actions, certain functionalities, certain computations which you would like to perform on the object are nothing but methods. Okay, so let's stop this session here.